All right, let's take a look at these. We're going to start with looking at some rational exponent stuff, and we're going to get into some radical things today. We may get around to doing another U substitution, but it depends on how much time we have. So when we're looking at stuff like this, where we have our fraction powers, that's x to the power of 3/4. I have a couple of ways we can rewrite this where it's not so fractiony. Because what do we know about this x to the power of 3/4? It's not the cube root. Well, it's the fourth root. The top is going to be our power. So this is the same thing as x to the third to the 1/4. So sometimes it helps to write this in a couple of different ways. I could put this as x cubed to the 1/4 power, which would be the fourth root of x cubed. That is absolutely valid and the same as x to the third over 4. Or I could write this as our x to the 1/4 that we would then cube. And there's going to be times when one of these is going to be easier to work with than the other. So these, the green piece and the purple piece, mean the same thing. They would all simplify down to be the same pieces. But if I want to solve this thing, what would I need to do first? How do I get rid of a fourth root like that? To the power of 4. If I put 125 to the power of 4, is that going to be a number we know anything about off the top of our head? No, because that's going to be gargantuan. If I wanted to solve it and I wrote it like this, what would I do here to get rid of that power of 3? Not square root, but close. Cube root. We need to get rid of that power of 3. If I take the cube root of 125, is that something we know how to do with? Yeah. So sometimes it might make sense to write it one way over the other. They both mean the same thing. You could absolutely take our 125 to the 4th and then cube root it. You'll get the exact same answer. One of them is just going to be easier to deal with. So I'm going to use this guy because I'm going to write this whole equation now as our fourth root of x cubed, which equals 125. And since I have my cube on the outside, to get rid of that, we take our cube root. As long as I do the same thing to both sides, that's totally fine. That's going to make my cube cancel out. What is the cube root of 125? 5. So we get the fourth root of x is 5. What do I do to get rid of that fourth root? To the power of 4. What is 5 to the 4th? 625. So you do not have to write it in both ways, especially if we can start to spot these pieces, thinking about which is going to be easier to deal with our number up there, with this number. You do not have to write it both ways, but oftentimes one of these is going to be easier to deal with than the other. So just think through them before we just start plowing through. You can do it either way. I just know that 125 to the 3rd is going to be very, very big. And so trying to find the fourth root of 1,953,125 is not what I know off the top of my head. Okay? So let's do another one. It's less gross-ish. There's a couple of different ways we're going to be able to deal with things like this. So our next one here, we've got our y to the 3/2 equals 5y. So I can't really approach it the exact same way we did here because I have y's on both sides, which means we're going to need to think about this as more of a factoring kind of situation, which means I need to get these guys on the same side of the equal sign. So what I'm going to do on this one is I'm going to subtract 5y from both sides to get my y to the 3/2 minus 5y equals 0. I can't combine them together because they don't have the exact same exponents, because this y has a power of 1. But what I can do, since this is 3/2 or 1 1/2, and this one is 1, I can factor out a y to the first. If I divide y to the first out, we're going to have y to the, what is 3/2 minus 1? 1/2. 3/2 minus 1 is 1/2. And our minus 5, if I divide out that y, we're going to just have our 5. So we like to have it kind of like this, simply because it's really hard to deal with two separate y pieces. You could do this as kind of a, no, it wouldn't work with the u substitution either, because it's not squared. So we really want to factor out something that they both have. So usually it's going to be whatever your smaller piece is that we're going to factor out. The benefit of doing this is because now I have two factors where there's only one y in each spot. We're going to have our y to the first equals 0 for one of our solutions, and we're going to have our y to the 1/2 minus 5 equals 0 for another one of our solutions. Well, this one I don't actually have to do anything with. It's add a solution right there. What do we need to do to this one to get to our actual solution? Add 5 on both sides. So we're going to have y, that's not a bend, y to the 1/2 equals 5. How do I get rid of that power of 1/2? Say it louder. If it was 1/2 y, we'd multiply by 2 on both sides. Absolutely true. That is a power of 1/2. Say it again, Mark.
Can we write it so it's like square root of y equals
You could absolutely write this as our square root of y, because that's the exact same thing as if this was our square root of y. Remember, that's our index of 2 equals 5. So then what is our y? 25. Because we would need to square both sides to get rid of that index. You can also see it here. If I take 1/2 to the power of 2, those 2's cancel out, you just get y to the first. So wherever you do it is totally fine, but that's where we're getting our second solution from. We're going to do another one like it where we're going to have to do a weird factoring. So sometimes we have to factor them weirdly. It's not going to be something we see super duper common, but every now and then. So we have one more on this page. Do you have a question? I can't hear it though. I'm happy to answer a question. Okay. Yes, dear.
Can you divide y on both sides?
The only problem with dividing by y on both sides is then we would not have our solution at y equals 0, because we basically changed the equation. We try really, really hard not to divide by our variables unless we have no other choice, because it can make one of our valid solutions disappear. So we do our very, very, very best not to divide by a variable. I was like, it happens occasionally, but it is super uncommon. All right, we're going to do the same kind of structure on this right-hand one. X to the 3/2 equals x to the 1/2. So you could rewrite it as roots or as powers if you want to here, but I'm going to start by getting the x's on the same side so I can try and factor something to not have two x's. So I'm going to set this as our x to the power of 3/2 minus our x to the 1/2. Set equal to 0. What I notice here is that I have two fractions that have the same denominator. They're both halves. I'm going to see what happens if we factor out an x to the 1/2. I'm going to take the smaller one, x to the 1/2. If I divide out an x to the 1/2 for my x to the 3/2, x to the first, because we subtract our exponents when we divide out the base. So 3/2 minus 1/2 gives us a 1. And then our x to the 1/2, when I'm dividing out my x to the 1/2, is just a 1. So if we try and factor out whatever term is smaller, it usually comes out as something way less gross. Because now I can deal with both of these pieces individually, and neither one of them is genuinely awful. Because we have our x to the 1/2 equals 0, which means what's our solution for this one? X equals 0. We square both sides. 0 squared is still 0. What's our solution for this piece? 1. X equals positive 1, because we said our x minus 1 equal to 0. Add 1 to both sides, x equals 1. So we've got 2 solutions on this one. And you can look at this and say x, the square root of x cubed and the square root of x, when those will be equal is when x is 0 and when x is 1. Every time else, x cubed and x squared are going to be different things. Yes, dear?
Are we always going to have 2 solutions or more?
Most of the time. The first one didn't. First one only had 1.
Yeah, because
But when we have 2 x's here and we're factoring something out because we're factoring out an x, so since we had 2 x's here is why we're getting 2 solutions, giving quadratic-ish. I was going to say, because if it was an x squared that we factored out, it could find up with 3. More often than not, it's going to be 2 that we see.
Okay.
Yes, dear?
Why can't you just subtract them?
Say it a little bit louder.
Why can't you just subtract them?
That's what we did here. Because they have different powers, it's like x squared and x. This is just x cubed minus x to the first, but they're both under square roots. Because I could rewrite this, wrong pen. Rewrite this line as our square root of x to the third minus the square root of x. I can't combine those together. When we have radicals, adding and subtracting, we can't combine together. It's if they're multiplied, I can combine them together. So it's not quite the same. I understand the impulse entirely, but we do have to keep it like this, because I can't combine those together. Again, this is not going to be something we see gabillions of and gabillions of, but just a little. We're more likely to see problems that look like these. So we're going to start dealing with a lot more radical stuff. So we worked with our radicals as exponents before. Now we're going to have radicals as radicals. So if we have the square root of 2x minus 9 equals 1/3, we want to try and solve this. We want to get all the way down to an x equals. That's our whole goal when we're solving, is we want x equals, or y equals, whatever letter we're dealing with. That's our whole goal when we're solving. So when we're dealing with square roots, how do we get rid of those square roots, those radicals? Say louder. Square both sides. But we want to make sure we have our radical by itself. Because if I square it when it's not by itself, then we get all kinds of weird things. So since I have my square root all by itself over here, I can come through and I can square both sides. Just make sure we're squaring the sides. Because the square root and the square are going to cancel out. We're going to get left with our 2x minus 9 equals what? What is 1/3 squared? 1/9. Then what should we do? Add 9 on both sides. Get x by itself. We want to add 9. That's going to give us our 2x equals, what is 1/9 plus 9?
82.
82 ninths, or you can say 9 and 1/9. I do recommend doing it as the fraction, 82 ninths, simply because it's easier to do any further steps with that. Because we don't want 2x equals, we want to know what 1x equals. So what do we need to do? Divide by 2. I don't want to divide this side by 2, and I want to divide this side by 2. Also known as times 1/2. Ooh, snap. What is 82 ninths divided by 2? What's 82 divided by 2? 41. So, 41 ninths. 82 divided by 2 is going to give us what number? You can always think of divide by 2 as times 1/2, and then I can simplify between these two pieces. So 41 ninths. Okay. And that's our answer. Questions on this first one? Okay, let's look at the right-hand one. We got this square root of 2x squared plus 1, and then minus 2, all equal to 0. What do we need to do first? Say that again. Add the 2 on both sides. We want the square root by itself first. If I just came through here and started squaring stuff, I would wind up with a middle term that still had a radical in it. So we don't want to do that. We do want to add our 2 to both sides so that I can have that radical by myself. We want to do our very, very best to not square when I have a radical and a constant, or a radical and anything else added to it. There's going to be times we can't avoid it, but we'll do our best. Now we're 2x squared plus 1 equals 2. Now what should we do? Square both sides. I want to get rid of this radical here. That's the whole point. I don't want to get rid of the radical. So as long as I do it to the left side, I have to do it to the right side. That's going to give us our 2x squared plus 1 equals 2 squared gives us 4. Then what? Minus 1 on both sides. We got our 2x squared equals 3. What next? Divide by 2. We get our x squared equals 3/2. So what does our x equal? Plus or minus the square root of 3/2. And these wind up gross enough that I'm not going to make us have to rationalize that, because these get really gross. Okay. Questions on these first couple like this? That's our answer. Right. What's up?
Can you take the x squared from the radical at the beginning?
You could, yeah. But not with that 1 in there. That plus 1 throws things off. If we didn't have this part, if we just had the 2x squared, that'd be fine. But this plus 1 messes with things. So I'm not saying it's impossible, but it is worse than this. It's incredibly uncomfortable. Yeah, you'd wind up with x squareds and denominators. You don't want to do that. You want to go this way. I understand the impulse to do that, though, entirely. If it didn't have the plus 1, I'm right with you. But that plus 1 tosses a wrench in things for us. Okay, let's look at our next one. It's going to be something like this. So now we have x's both inside and outside of radicals. We've got our square root of 7 minus x set equal to x minus 5. And we have on the left side here our radical all by itself. We love that because that makes things way easier to deal with. So if I just like ignore this side, I can see I have my radical all by itself. So if I want to get rid of that radical so I can figure out what the heck this x is, what do I need to do to that side? Square it. Which means what do I need to do to this side? Square it. The whole side, not each individual term. We need to square this side and square this side. The square roots cancel out over here, so we're getting our 7 minus x. What is x minus 5 as a quantity squared? Minus 10x plus 25. Do not tell me it's x squared plus 25. Don't tell me it's x squared minus 25. Those are the two most common mistakes I see on these kinds of things. Is we're like, sweet, squared, x squared, 5 squared. Moving on. We got to have that middle term. It makes a difference. So now I don't have any more radicals, but I do have an x squared. So what do I need to do to try and solve this? Set it equal to 0. So I can do that by moving everything from the right to the left, or I can move the stuff on the left to the right. Either way, I just got to get them combined together. Since I already have an x squared on the right, I'm just going to go ahead and add x from this side, and then subtract our 7. You can do them both in the same term, or if you want to do them in separate steps, that's totally okay. That's going to give us on the left-hand side our 0 that we wanted to have. I've got x squared minus 10x plus x gives us a minus 9x. And 25 minus 7 gives us 18. Ooh, positive 18. How do we solve that? Factor. It factors. I need a pair of numbers that multiplies to make a positive 18 and adds to make a negative 9. Negative 6 and negative 3. Since we have an a value of just 1, I can take the shortcut and go straight into my factored form. Because when that a value is just 1, I know that the front term is going to be an x, and the back term is going to be whatever those two numbers are, my minus 6 and my minus 3. This shortcut only works when this is 1. Stop using it for everything. It only works when this is 1. Otherwise, you have to actually do the work. So what do we get for our solutions? What do we have? Our x's are positive 6 and our x's are positive 3. And if you want to, you could go up there and check and see if it works. See if it makes sense. They both work. 7 minus 6 gives us 1. Square root of 1 is 1. 6 minus 5, 1. It works. Okay. Questions on this one? We have 2 more with radicals, and each of them takes a little notch up. So the next one's a little notch up. It looks gross. We can do this. We've got the square root of 2 square root of x plus 1. On each side, 2 radicals. Blinky screen, what are you doing? Thank you. Even the screen went, I don't want to do this. And that's set equal to the square root of 3x minus 5. Ew. It happens sometimes that we get square roots stacked inside of square roots. They could switch everything to be fractional exponents, and we can rock with that, but it's just kind of easier to blow through it this way. So what we're going to do is kind of work from the outside in. I see on both sides, I have square roots as my outside-iest pieces. So So my very first step is going to be to square both sides and see how many things I can get rid of. I want to square both sides so that this guy cancels out and this outside one cancels out. It does not cancel out both square roots on the left side. It only cancels out the outside one. So we're going to have our 2 square root of x plus 1 equals our 3x minus 5. I don't know why that 2 is markedly bigger. There we go. Now it at least matches. Okay. What's our instinct next to do? Divide by 2. You absolutely can. If I divide by 2, though, am I going to have nice numbers over here? They're going to be fractions. Fractions. This is 2 times the radical. 2 times square root. I can leave it there and not have to deal with fractions. Or you can divide by the 2, wind up with fractions, and keep going. You'll get the exact same answer. But since this is 2 times square root of x plus 1, you could think of it as 2x and 2x. If I just square this side, I won't wind up with fractions. And it will still cancel out my radical. It's just 2 square root of x plus 1 times 2 square root of x plus 1. So we're going to wind up with 4. And instead of the square root, we just have our x plus 1. Because our 2 times 2. You do not have to, if you want to divide it by 2 and then square it, totally fine. You're just going to wind up fractioning. But our right-hand side is going to be our 3x minus 5 squared. If it helps, write out your square as multiplication so that we do not lose track of that middle term. You don't have to write that stuff out, but I know for some of us it helps because the most common thing we forget is that middle term because we do need to multiply this out because we want to get down to an x equals. So we need to distribute out our left-hand side, and we need to distribute out our right-hand side. So we're going to have our 4x plus 4 on this side. And our right-hand side, 3x times 3x gives us a 9x squared. Our 3x times minus 5 gives us minus 15x. This is also a minus 15x, so we have 2 of them. So we get minus 30x. And then we have our minus 5 times minus 5. That's plus 25. If it takes you a couple of steps to write this out, that's totally okay. You do not have to make this big jump. I just combined these like terms and these like terms as I was doing it. So now we are rid of all of our radicals. Huzzah. But we're left with an x squared. So what do we need to do to be able to solve for an x squared? Yeah, because whenever we have an x squared, we need this thing to equal 0. So I'm going to minus 4x from this side and minus 4x from this side. I'm going to minus 4 from this side, and I'm going to subtract 4 from this side. So that's going to give us that our 0 equals 9x squared minus 34x plus, and again, we're trying to get down to our x equals. You can quadratic formula this. It does factor, which is easier, but will take a little bit of work because we need to find a pair of numbers that multiplies by a times c. 9 times 21, which is 189, and has a, so they multiply to be 189 and add to be negative 34. So we need a pair of factors that make 189 that have a sum of 34. I think I heard it. It was in there. We had our 7 and 27. But if they're adding to make that negative 34, they're both negative. Because that top number is positive, that means they're going to have the same sign. So we have negative 7 and negative 27. You can factor this with the box. You can factor this with grouping. However you want to do it, I will put grouping up here on the board. I don't care how you factor, just that you factor. If I can't figure out what's happening, I will ask you. But this gives us our minus 7x and our minus 27x plus 21. Because it's just uncombining these like terms. If I combine these back together, I'd get exactly what we had here. We're just splitting them apart in this very specific way. I always have a plus between when we are grouping. Makes things easier. So we're going to have our 0 equals. Share between our 9x squared and our minus 7x is an x. And left over is going to be 9x minus 7. Shared between our 27x and our plus 21 is a negative 3. Whenever we have a minus sign right here, we do need to take that minus out. We almost never have minus signs over here. So watch out for this minus sign. And that's going to leave us with a 9x minus 7. So finishing our factoring, we get our 9x minus 7, that matching set, these two pieces. And our leftover bits make the other factor, our x and the minus 3. Make sure when we are factoring, we get all the way down to actually factored. This does not count as factored. This is half factored-ish, kind of. So this is not factored. This is factored. This, you have to keep going. But we're almost there. We can get to our solutions. What is our x going to equal? Yeah, so if I take my 9x minus 7 equal to 0, we'd add 7, so it's going to have a 7. And then we would divide by 9, so 7 ninths. What about for this one? Positive 3. So x minus 3 equals 0. Add 3 to both sides, we get 3. So these are our two solutions. Okay. We're going to have one more kind that we see in this homework, and it's gross. Like this one is bad. There's one other kind we see. So this one will be our last one for today. We're not done with it. Oop. And this one has 3 radicals in it. We've got the square root of 7 minus 2x minus the square root of 5 plus x, all set equal to the square root of 4 plus 3x. And this one doesn't look like it's going to be that gross, but it is. And the reason this is going to be gross is this minus sign right here, because we're subtracting these two radicals. Because I can't combine them together when it's subtraction between them. If they're multiplied, we'd be ready to go. But since they're being subtracted, or if they're being added, we can't just combine them together. So what we're going to do is, I have over here a radical all by itself. So I would really like it if we could square it to get rid of this radical. But if I square this side, we also need to square this side, which is going to be genuinely kind of awful. Because think about what it means to square. We'd have this squared, and the middle term. I'm going to write the whole thing out as like the 2 parentheses, so it's like factors. Our square root of 7 minus 2x minus the square root of 5 plus x times square root 7 minus 2x minus square root 5 plus x. And that's going to equal, here at least we've had some things cancel out, our 4 plus 3x. The problem with this piece is, with this equation is in this multiplication, because yes, These two things match. So when I multiply my first term times first term, our roots are going to cancel out. But when I do my outside piece or my inside piece, they don't cancel out. So I'm going to do it with the distribution. I'm going to show you. Because we have our this one times this one. That's our square root of 7 minus 2x times square root of 7 minus 2x. So that's our square root of 7 minus 2x squared, which is just going to be our 7 minus 2x. Then we're going to have our 7 minus 2x times the square root of 5 plus x. Those two pieces don't match, so I cannot just cancel out my radicals. So what we have is the square root of 7 minus 2x times the square root of 5 plus x. And you can do it as two separate radicals like this, 5 plus x. Or we can realize, oh, if I have two radicals multiplied together, I can put them inside the same radical. You can write it either way. Doing it this way will make it easier. And these are genuinely awful. So that's our first term, gone to the two second terms. Then when we do this data here, our square root of 5 plus x times the square root of 7 plus 2x, I get another one of these, exact same thing. So I could write it again, or I can go, hey, wait a second, I got two of them. And then our last piece is our minus square root of 5 plus x times our minus square root of 5 plus x. We're going to get our plus square root of 5 plus x squared, which is 5 plus x. And it all still equals that 4 plus 3x. Ew. But now we're down to just one radical. So we went from 3 radicals all the way down to 1. That's better, because now I know how to deal when I have one radical. That was these guys. Get our radical by itself, then square. So on this guy, I want to get my radical by itself, which means first thing I need to do is combine my like terms together. So I'm going to combine my like terms here to see that my 7 plus 5, my goodness, there we go, 12. And my minus x plus x gives us a minus 1x. And then we have this thing, minus 2, square root of this hot mess. 7 minus 2x, 7, 5 plus x. I still want to get that radical by itself, so I'm going to try and get everything else to leave. So I'm going to subtract 12 from both sides. I'm going to add x to both sides. That's going to leave us with minus 2 square root of our 7 minus 2x, 5 plus x equals, and you can keep them in this order, or we can flip-flop things around and put the x's in the front, numbers in the back. Either way is fine. I'm going to put my 4x, 4 minus 12 gives me a minus 8. If you put it as minus 8 plus 4x, that is 100% okay. I am going to change the view just for a second, just so I can get a little bit more paper so I don't have to write so small. What should we do next? Divide by negative 2. I recommend it. The reason we can do it this time and that we didn't want to last time, 4 and 8 both divide by 2 nicely. I'm not going to wind up with a fraction over here. If we were going to get a fraction over here, then we might consider leaving it here to square. But since I'm not going to get a fraction, let's be rid of it and not have to worry about it. So we're going to now have our square root of 7 minus 2x, 5 plus x, equals, divide this by negative 2 and this by negative 2. We get negative 2x plus 4. And now we have just one radical. So we can square both sides. That lets the square root and the square cancel out finally. So we're going to have these two factors. Sorry, trying to not be before. Are 7 minus 2x, 5 plus x, equals our minus 2x plus 4 squared, or times minus 2x plus 4. Ooh, that was green. There we go. Which we can then multiply out. We can do these things. When we multiply this out, we're going to wind up with, I'm going to do a force real quick just because I don't want us to get all the way to the bottom. Minus 2x squared minus 3x plus 35. And when we multiply out the right-hand side, we get 4x squared minus 16x plus 16. We are going to want to set it equal to 0. That's going to give us our 6x squared minus 13x minus 19. That does factor, and it gives us our solutions. And I'm sorry it took us all the way to the bell. I tried. But we could then factor this. We will do a little bit more work with these tomorrow. But that's kind of the most of this chapter is dealing with these radicals. There is maybe one of these. I think one on the homework like this. They're awful. And I'm sorry. They make us do them. I will finish the factoring before I post the notes up for it, just so you can have it in case you want to look at it.